Hello everybody. In today's session, we will learn how to download satellite data from Earth Explorer. So this is the interface that you see. You have to ensure that you are logged in. And when you're logged in, this is the kind of interface that you see in front of you. You have search criteria this side and you have a map view here. So first we have to go to our region of interest. I am trying to download some data for this region. So come to search criteria, and here as you go down you will see polygons, so you can use map. So you will see that 4 pins have come and these are movable, so you can move them to the region that you want. And then any time if you want to delete any, then you can use this cross buttons. Now I want to search for more. If you want to search for a specific time period, then you may do this. If there's nothing else, you can go to datasets. The kind of datasets that we want to download is Landsat, and I'm going to download collection to level 2. This is atmospherically corrected data, and I want to download Landsat 89 OLI. Okay, these are the recent sensors in Landsat, these are the recent satellites. So you can go to results. Now you should be able to see some thumbnails over here with which you will get to know whether the given data set is covered by some cloud and things like that. So you may keep moving next to search for different data set and identify the most suitable one. The most suitable one will be without any cloud cover. So I'm simply searching for some data set. Next. I'm using these thumbnails to identify data which is without any cloud cover. You may also just have a look at the footprint. So this is where the data belongs to, and if at all you want to see how the data looks, then you may click on this option, wait for it to be loaded. And I feel this is very much without any cloud cover, so I may go ahead and click on download options. I will get several download options, of which I have to choose the surface reflectance bands, and I would want to add all files to bulk download such that I have um, the entire data set. So we will download this product bundle. Wait for it to start downloading, and you have to store it within a particular folder. I will call this practice, and let us save this over here. Now this will take few minutes to download. Let me pause until then. So now, as you can see, we have downloaded Lancet 9 data, but it is in zipped format. So what we are going to do is we are going to first unzip it. That is, you can use um, any small tool to unzip it, like that of WinRAR, or if your device is younger, then definitely there has to be an inbuilt option to extract it. So let us extract it. Let it complete. Once it is extracted, you will see a folder, and now if you want, you can delete the zipped file. Come back to your QGIS. So the first thing that we are going to do is we are going to create, let me remove this. So the first thing that we are going to do is we are going to add uh, the several bands that are available within that data set. The data set is lying on my desktop within practice. This is the data set, and it comprises of several bands, essentially 11. So you may view them as details and slightly extended such that you can see which bands those are. So we want to bring in band 1, 2, 3, 4, 5, 6, 7, and okay, so these are the bands, band 1 to band 7. These are the ones that we are bringing in. Add them and close. So you can right click, zoom to that layer. So this is where all these bands are lying. We are going to make a histogram out of all these bands, and in order to do that, we will first have to make a virtual raster, and for that you go to menu bar where you have raster option. Under raster option you go to miscellaneous, and under miscellaneous you go to build virtual raster. Now here you have to add all these 7 bands. Select all the bands, input them. So you have 7 inputs selected. Change this to highest resolution and place each input file into a separate band. If you want, you can save this permanently within your system. If not, you can run this, so it will come as a temporary layer. So this is the virtual raster layer. You can right click, go to the properties, and go to symbology, and you can change it into different combinations. So I am changing it into true color composite, wherein red band is given red color, green band is given green color, blue band is given blue color. Apply it and click on OK. Now what you see is true color composite. Vegetation appears green, or barren land appears brown, how otherwise humans say it, and water appears blue. So this is true color composite. The next thing that we are going to do is we are going to create a um, histogram out of all this. So yet again, go to the properties, and this time you have to go to histogram. Right now you don't see anything, it's a blank canvas, so you have to compute histogram, and now you will see all the bands being populated over here. So these are the different bands. Each one is given um, a specific color, and they represent reflectance. Okay, so you see, when it comes to pink, that is blue band. It is actually blue band. You might want to go back and check the table of Landsat 9, and you will realize band 1 is blue band, that is coastal aerosol band. So here you will see highest reflectance is seen somewhere here. that is around 5,000, 6,000, 7,000, 7,200, something like that. Okay, so um, so different peaks have formed, but what if you want to see only for one band? So for that, what you do, you go to prefs slash actions and show selected bands, and then select band 1. This is band 1. Then for band 2, and for band 3, band 4, because all of them together, if you were to see, then it becomes slightly difficult to discriminate between them, isn't it? So if you want to save these, then you can simply click on this save plot. So this is band 1. What I will do is I will save this. I will create one more folder here, new folder, and I call this histogram, because I intend to save this histogram. So this is for band 1, that is band 1 is coastal aerosol. Okay, so for coastal aerosol, and then save this. If you want, you can save it as a png, whatever that you want, and then save this. And then as many as you want, you can save, and then you can click on okay. Okay, so if you go to that folder, you'll find the histogram being there. It has been saved. Okay, now the next is wherein we will be making spectral signatures for different objects. Each object has a specific spectral signature. It reacts differently or interacts differently, has different reflectance in all along the electromagnetic spectrum. For example, vegetation, you will see it has a higher reflectance in green and lower reflectance in red. That is why when vegetation has chlorophyll content, it is alive, it appears green to us, but then it has even higher reflectance in near infrared. Only the difference is because humans are not able to see near infrared. We don't really see them in near infrared color, we see them in green color. That is the next highest reflectance. So for this we require to install a plugin. To install a plugin, we have seen this earlier. You go to plugin manager, install plugin. Make sure that you go to all. If you are in install, then you won't see this. Go to all and search for semi automatic classification plugin. This is the symbol that you have to remember. And then because I have already installed it, I get a reinstall option. But then make sure that you install it and then close this. So you see scp over here. Okay, and then we go to spectral plot. So we go to this scp, go to band set, and you can use this, open a file to bring all your bands from here. But if your bands are lying here in the layers, then you can simply click on plus and select the bands. As you select the bands, click on ok. Once the band set is made, if you want, you can create a virtual raster of this band set from here. You can click this and click on run, or you can also create a stack band. Basically, virtual raster and stack bands, both of them are similar. Now, as we do this, you can close this down. Yet again, just open and make sure that your band set 1 is still there. Now you have to right click, go to scp doc, and open this scp doc panel. And here you are going to go to training input. Here you will create a new training input. Create this over here, call this training input. Training input, it is for spectral signature, spectral profile. So go ahead, make the spectral profile, name it, and save this. As you save this, now you have to make some samples. In order to make samples, you are going to take some ROIs. So first, let me give a macro class ID. So I want to first take some samples of water. So and its MCID is 1. So class ID is 1. For 1, we are going to do this now. Um, so in order to do this, you have to take ROI. So you can right click on over here and search for ROI. So where here you see semi-automatic classification plugin. So all along this you will find the ROI symbols. You can tuck it to the lower end. If you want, you can remove any so that you are able to see the entire stretch of this toolbar. We will take one ROI, that is activate ROI pointer, and let us take some samples from water. So we will call this clear water. This is clear water. We will make, you may choose to use this plus, or you choose this polygon as well. Let's just try making one using this. So it has already taken. You can save this so that it gets saved within the symbols. And now you are going to do for the class 2 same, that is clear water. Let me take this polygon and let us take some sample over here. Right click to close the sample and click on save. So we are still collecting for clear water that has macro class ID 1. So this is it. Now next let us take MCID 2, that is turbid water. So turbid water, again class ID is going to be 1, and this is turbid water. So let us yet again take a polygon and collect a sample from here. This is turbid water. Save this. Then take another class 2, that is, and you can take that from here. Save this. Now besides this, let us try collecting some samples from maybe vegetation. Let's try finding some vegetation if we are able to. It seems to be agricultural land. There might be no vegetation in here. Let's still try. Seems to be some vegetation here. That's again, it is agricultural land. So we can take some sample from here. So we will call this vegetation. Then again, class ID will, macro class ID will be 3, class ID will be 1, and let us take a sample from here. Save this. You may take as many as you want, one from here, maybe one from here. Save this. And as you do this, if you have any barren land, yes, so here we have some barren land. Take some barren land as well. Macro class ID will be 4, class ID will be back to 1. Take some, make sure that you don't contaminate the sample. Save this. Second class we will take for barren land, maybe somewhere from here. Okay, so this is done. Samples you have collected. Now we will go for signatures, to find out the spectral signatures of all these data. For that, we click on add highlighted signatures to the spectral signature curve, and now you can select all these signatures. You can use control A as well to select all these signatures. Once you have selected all the signatures, if you come here, then you have this option called add highlighted signatures to spectral signature plot. So when you click on this, you will see that different colors have shown up. If you want, you can change the color. For example, if it is clear water, let us give it some deep blue color. Click on OK. Let us try adding them here. Just deselecting them all so that we can assign some specific color to these. So clear water will come in this color. Turbid water, let's make it blue, but this should be okay. And vegetation, green color. Barren land, let's make it brown in color. When we set these colors, now we can yet again select all of them and add signatures to for highlighted items. Select all of them, and you can click on add highlighted signatures to spectral signature plots. This is when you will get these colors, and here you see that both the turbid waters have a different signature as compared to clear water, and vegetation, and then this is for barren land. These are the different wavelengths that are available. And to make this a little more authentic, you can in fact check which bands these are from. These are coming from. These are coming from Landsat. So you can check which wavelength they belong to. Landsat 9, these bands are LC09 means Landsat 9. So if you have chosen this, then yet again keep all this selected, and yes. So this is to do with spectral signature curves. You can save this again, use this particular option Save the plot to file. You can save it as JPEG. Then save. This is to fit it to the entire plot. Save this plot to file. Okay, I'm not able to save this, but you can save the signatures from here. And then that's how you do spectral profiling and histogram calculation. We'll stop here.